All right, so everybody, welcome to Math 45. This is office hours. We'll handle any sort of questions about the class earlier on, which we did a little earlier. And then the second part of office hours is just for me to run through the lecture on chapter 1 and the rest of the chapters here. So I'm going to just go for it here. And if you have any questions, please ask away, because this is what this is. But essentially, this is the teaching aspect of the class. So chapter 1, what it's all about. In fact, the whole entire book, what is the whole entire book about, is all the stuff you did not get to in algebra. Essentially, you've done intermediate, elementary algebra, intermediate algebra, and these are the leftover stuff. So chapter 1 is about elections. We'll go into finances. We'll go into graph theory. We'll go into scheduling, and we'll go into statistics. Those are kind of like the big main heads in the book. But it's kind of like, it's all the offshoot stuff that we never got to. That's kind of where we're at. So anyways, the chapter 1 is all about elections. And so how do we count elections? How do we count ballots? And not just political elections, but any kind of elections, any kind of thing that you draw up, you vote on something. And hopefully you kind of get this sense by the time we're in with this chapter, is the fact that there's no such thing as a really, really fair election that gets everybody's vote counted perfectly. We just have come up with systems to take care of as much error as possible. That's essentially chapter 1. So, but let's go through it. And we're going to cover, since we have 2 times to do this, we're going to cover sections 1, 2, and 3 today. For Thursday's office hours, we'll cover 4, 5, and 6. So let's jam. Let's go with it here. So chapter 1, it's the basic elements of an election. That's what we're going to look at in 1.1. A lot of definitions here. So first things first is voting theory involves 2 things. And we look at 2 things here. The first one is the voting itself. How are people casting their ballots? How do they do it? How do they check mark? Do they vote for only one person? They vote for their like 1, 2, 3, their top 3. How does that happen? The second part is counting. How do the votes get counted? Is who gets more votes? That's it? Is just a majority vote? Do we start doing elimination? That's kind of things we do in the second half of the counting piece. And then Mr. Arrow, as he was studying this, he comes up with this Arrow's impossibility theorem. So there's what his quote is: the method of determining election results that is democratic and always fair is a mathematical impossibility. There's no way to make the fairest voting system. We just have certain rules that apply and as long as you abide by those rules, the election is valid. All right, let's go. More definitions. So the paradoxes here is that the more opportunities we have to vote, the less we seem to appreciate it. So just the paradox democracy is not a lot of people vote. We don't have 100% turnout on voting system. So the other piece is why is that the case? Just food for thought. So why should we vote? Does our vote really count? Does it count at the presidential level? Does it count at the state level? Does it count at the local level? I don't know. That's kind of for us to sort of think about as well. But let's get into the mathematics of it. So elements of election, here it is. So you have candidates, people, places, movies, pizza, whatever you are going to score. You have the people that are going to determine the outcome. They're voting. And then you got the ballot system. And so again, it could be a single choice. You just pick one and that's it. It could be a preference. So you rank all the candidates from the highest to the lowest, or then you just rank the top 3 or the top 5. And that's usually how ballot systems work. And depending if it's a presidential election or a state office election, sometimes that's what we do in March. We have preliminary elections. So vote for your top 3 candidates. And then you have the runoff election. And so you have all these different rules that center around how elections are made. All right, let's go this one here. So then you got the outcome. And the outcome, you just have one winner. So this person is elected mayor of the city. That's it. You can't have 3 mayors. Then you have a partial ranking. This is top. This is the first, second, third, or then you have the full ranking. And then this is the system of voting. how we tabulate the ballots to produce the outcomes. So what we have to do is, this really is the nuts and bolts of it. So we have to decide on what method are we going to use, and we're going to study all these different methods throughout chapter 1. And then we're going to agree ahead of time how things are going to be counted, which votes count, which votes don't count, all those complication of rules that we look at. And just, we've seen it on the sort of like the last presidential election, where certain things were counted, certain things were not, certain votes were counted and certain were not. Mail-in ballots was an interesting thing because all these different states had different rules how you count mail-in ballots. So it was crazy, but this is that whole part right here. It is the most complicated part, handling the rules, deciding the voting system, and then which ones are going to be counted and what are the rules agreed upon ahead of time. And that tends to be crazy as we go through them. All right, so let's do one easy one here for us. We have a Math Appreciation Society at our college. It is a student-led club, and it's made to foster the enjoyment and appreciation of mathematics among college students. Wow. Okay, so we are going to hold an office, and we have some candidates. We have Alicia, Boris, Carmen, and Dave. How about ABCD for short? So each member in the club is eligible to vote, and the votes take a place of a preference ballot. So it's going to say, you want this person to be president, you want, and then you say the second one you want president, third one, and fourth one. So here's the ballots. Here's the results that happened. So yeah, 37 members, so 37 voters. And we have all these ballots. There's 37 of them. So it listed Alicia, Boris, then Carmen, and then Dave right here. So that's the first ballot. Then you had a second ballot, a third ballot, a fourth ballot. So the question is, how do we determine a winner from all this? What would be the most fairest way of doing it, if we can say that? And how do we score? How do we know who won? And how do we tabulate? So just trying to get into the mystery of this. We're good. That's what I want to sort of see. Before we get to that piece right here, I just want to say this system of preference balloting, it's not just in the math class. So I just kind of went on to just places where this is done. A preference ballot. So Academy Awards or the Oscars, it is a ballot system. You have, the ballots are gone to, let's see, the panel selects 3 people. And from those 3 people, it goes off to critics in the movie industry. It goes off to directors. It goes off to other actors. And they bring a preference ballot. Yeah, this person should be first, this person second, this person third, just like our math example. And from there, they declare one winner for the Oscars, for the Academy Awards. Now, the Heisman Trophy winner, if you guys are into football, that's exactly how it's done. It goes to coaches, it goes to TV announcers that have like really understanding of football. It goes to all those, and it's a truncated preference, which means you pick the top 3 or the top 5 candidates. And from there, then they do this counting system. And American Idol. That one is a single choice ballot. At the same time, there's a whole bunch of ballots, and then it's an elimination system. So the person with the least amount of points, he gets eliminated, and so on and so forth. But still, it's a preference system. So yes, this is made even on a show that some people watch. I'm not sure if you watch it or not, but there's a ballot system method on the background to make sure to see who actually is the winner, or in fact, the loser who gets eliminated. Okay, so yes, there's all those things that happen. So question is this, what do? We have to understand that the higher position is always the preferred position over the lower position. And that's how it's made. That's how we sort of think about it. And then we think about relative preferences. What happens if the candidate's withdrawals. What happens to those points? Because there's points, should those points be lost? Should those points be added in? And how, in which way should those points be added in? That's another piece there that comes into play when you do a ballot system. But let's go back to our example for our math class society president. There it is. There's our 37 ballots. And we can kind of see, notice the ballot number 1 here, it says A, B, C, D. And this one over here, ballot, this one, A, B, C, D, it's the same exact ranking. So this ballot and this ballot, 2 out of the 37 people that voted, they had the same exact order of these. So what we can do is we can actually just stack all the ones that are the same on top of themselves. And that's the first thing that happens here. So there it is now we're grouped together. We have grouped ballots. And looks like 14 people chose this designation right here as their preference. 10 people, 8 people, 4, and then 1. One person decided that Carmen deserves to be president. And in this way, but then also notice Carmen is first over here. So 10 people wanted Carmen president, and then the rest ranking went in this order. And so how do we combine the results? We have to make a little table. That's so based upon this information, we move on to making a little table for the stuff here. So 14 people voted in this way. So A, B, C, D. 10 people voted in this way, C, B, D, A. And so as we make a little table, I think this is just to say, yeah, we have to have a way to summarize the input. And usually that's in terms of table. So the table for this is going to look like that. See if that makes sense here. So first place votes, 14 was for Alicia. Then you got 10 for Carmen, 8 for Dave, 4 for Boris, and 1 for Carmen again in a different order. So the question is, who should be president? That's the question. And in 1.1, I don't think we actually even get there. We just talk about the setup. So 1.1 is really just, it's just the definition, and here's your elements. So we went through one, I don't know, how would you say, one iteration of getting the votes counted. So now the question is, before we get into the actual nitty-gritty numbers of it, so the question is, what happens if there's a tie? And then all those rules that we just talked about, those rules also have to handle a tie. And if there's a tie, who's going to have the determining factor? Who's the more popular candidate? And so some of them have rules. Some allow it to stand. You can have a tie. So you can have, normally that does not happen, just like games. But yeah, you can have it a tie. Could be one of the rules. 2 people are going to do this. But normally that does not happen. So in elections, like any kind of election, there's going to be a runoff election. So any mayor election or a presidential election, right? There's going to be a runoff for that. All right, and then you can count the votes from the back end. You can count it to say, hey, this had the fewer bad votes. And so then the other one that had the fewer bad votes wins. Or what you can do is you can then recount everything in terms of just a head-to-head winner. And the last one, yes, it does actually happen. There's, I think, 3 or 4 mayor races, not in California, but 3 or 4 mayor races that were really decided by a flip of a coin. So true. I think there's been 3 mayor races in the United States that went down to a flip of a coin. Okay, so 1.1 is done. Hopefully you kind of understood this process, and hopefully understood that ballots are kind of a little more complicated than just putting your vote on a sheet of paper here. So now let's get a little bit into the numbers. This is 2.2, 1.2, sorry, a little bit into the numbers here. So the first thing, so notice 1.1, we just did the pieces of an election. So now the question is, what methods are we going to employ in order to count? So here it is, the plurality vote. It's the most simplest one. So we're going to talk about now methods. These are the methods of voting. We have 1.2 is the plurality vote, 1.3, and so the rest of the chapter really is going to be about the different methods. In fact, 3. So 1.2 is going to be the plurality vote. I'm sorry, 1.2, yeah, 1.2, I think I said 1.2. 1.3 is going to be this called the Borda count method. Not because he's bored, but it's the last name of the guy that invented it. 1.4 is going to be the plurality with elimination. So it's a little tougher one to do at 1.2. So there it is. There's that one. That's 1.4. And I'm just scrolling to see what else here. 1.5 is going to be comparing. It's called pairwise comparisons. That's another method of how we do this. And 1.6 is going to be arrows now. The whole point of, is it fair or not? That's kind of what you're looking at there. All right, so let's get started here. It's a plurality vote method. How do we do this? Definition here, simplest, most common. You'll find this a lot, is determining the outcome. So what do? We only count the first place votes. Candidates with the most first place votes wins. If a candidate wins over half of the first place votes, they are automatically a winner. And if they don't get 50%, then there's going to be a runoff election ever. So real quick here, the vast majority of political office elections in the United States is this method right here. All right, so when was this? Let's take a look at something here. So I made this little screenshot here of the last, the 2020 Fresno mayor election. I'm from Fresno. There's a guy named Jerry Dyer. He was the sheriff of Fresno for many, many years. And so on March 3rd, 2020, when people cast their elections, he got 51.6% of the vote right there against Andrew Jans. So what happened here is there was no runoff election. Plurality vote won. He actually won the majority. And so in November, there was no election for him. He was already considered the mayor-elect. If he would have had 49%, then there would have been a runoff election in November. So that's exactly why we do preliminary elections or primary elections in March or April, depending when the state does it. And then you have your runoff election in November, because we are using the plurality vote. Okay, so let's go back. You guys remember the math club election for the president? So let's go for it here. Let's do this here. Just like the Fresno mayor, let's count this up and let's see who won if we're going to use the plurality method, counting method here. So first place votes count only, and let's go with it here. So Alicia gets 14, Carmen gets 10, Dave gets 8, Boris gets 4, and Carmen gets the next one. So Carmen actually gets 11. And so we go with it here. A gets 14. So Carmen 14, 4, 11, and 8. So now the question is, did Alicia, did she win the majority vote? And doesn't look like it, right? Because 14 would not be the majority out of the rest of these here. Maybe so. Let's see. Hold on. Let's see. That's 18, 19, 20, 21, 22, 23. So if I count all these up, how many? Oh, there was 37, right? There was 37 total. So 14 out of 37 is not more than 50%. So they would have to do a runoff election possibly. All right, so let's go with it here. So with more than 2 candidates, a majority, more than 50% cannot be guaranteed most of the time. So then what happens here is the results are highly manipulated. And so you can make the majority votes. You can, some people don't vote because they figure the person's not going to win anyways. And so the drawbacks of it, yeah, you're going to have 2 elections for sure. And that's why in America, we do have primary elections and November elections. It's already built into our system, assuming we're not going to get the majority vote. And so with it, yeah, the small votes do count in a sense a lot more. And here's the clincher, is that sometimes, as we'll see a little bit later on, a candidate maybe overall actually maybe preferred higher than the other candidates, but they didn't get the top % votes, so they don't count. So the question is this fair? Well, fair according to the rules, yes. All right, let's do, I think, one or two more examples here. So Tasmania State University has a superb marching band. They are so good that it's coming bowl season. They have invitations to perform at 5 different bowl games. So R is for the Rose Bowl, H, the Hula Bowl, and the Fiesta Bowl, the Orange Bowl, and the Sugar Bowl. There it is, RAHFOS. So we have 100 band members, and they are given a decision of where do they want to perform. Each band member submits a ranking of the 5 choices, and let's go with it here. So if you're a band, how would you decide which way to go? So the ballots were cast, and here it is. We're summarizing the data now. And here's what the data said. So first place votes, there it is. Rose Bowl, 49. The Hula Bowl was 48, and the Fiesta Bowl was 3. So who wins according to this method? It's going to be the Rose Bowl. Rose Bowl is the winner by 1, right? And so I think we're going to come back to it in just a second here. Yes, the Rose Bowl with 49 first place votes using the plurality vote system is going to win. The Hula Bowls came in second. So by the plurality vote, absolutely, the band is going to the Rose Bowl. But here's an interesting thing. Let's go back at the data. So wait. Even though it won, let's go back to look at the data. Let's take a look at this stuff here. So Rose Bowl here had 49, is that right? But notice, for some reason, let's see, 48 plus 3, that's 40, that's 51 people, is that right? That's 51 people, according to this ranking, they actually did not want to go to the Rose Bowl. So there's a majority of the band members that do not want. There's 51 people that don't want to go to the Rose Bowl. But there's 49 people that rated it highly. So notice plurality vote, this guy wins. But notice H, notice the Hula Bowl came in second here, right? Came in first here, and then also came in second here. So would it be almost safe to say for the majority of the people, the Hula Bowl is actually a better preference than the plurality vote? So notice, it's kind of funny, isn't it kind of crazy? Our political system is made up of this voting system right here. First vote counts, that's it, you're done, right? And then you can have this situation happening. So on the homework, you're going to say, use the plurality vote. Who won this? And you're just going to say the Rose Bowl at that point, because you're just counting first place votes. But I want you to just dig a little deeper and notice that little stuff in our data. So is it fair to dismiss this? That's a choice for a person that makes the rules. All right, so let's go on here. Yes, the Hula Bowl received all first and second place votes. That was super popular. And in a head-to-head comparison, which we'll talk about a little bit later, the Hula Bowl wins totally. Right then and there, just wins outright. So I've got to be mindful of that. So that makes us come to this little piece right here. It's called the coordinate candidate. So you'll have some examples on the homework here. But let's read it here together. So the candidate preferred by the majority of the voters overall, when the candidates are all compared to each other on a head-to-head comparison, is called a Condorcet candidate. So not every election has a candidate like this, but there may be one. It's a good sign that this candidate represents for the voters the better choice overall by not the plurality vote. So in the bowl example, the Hula Bowl is this Condorcet candidate. So again, we'll discuss this guy a little bit later on in the course. But just out of curiosity here, so what I also did is I just picked some homework assignments. That'll be something you'll see. So we'll kind of just do it together here. So here's a homework assignment. I called it example 1, but here's what typical homework assignment would look like. So let's just kind of do one together real quick. So table 1.32 shows the preference selection for 4 candidates, A, B, C, D, plurality vote. So find the winner of the selection. So let's see, according to the plurality vote, right? So I got A has 21 votes. B count is 18. C is actually 11. Is that right? Because you count the 10 and the 1. And D would be 29. So there's by plurality method. That's what the winner is right there. So find the winner, plurality, absolutely. Oh, don't go that there first here. Now the question is, can you rank these? Yeah, rank them. D is first, right? A would be next. B would be the next one. C would be the last. So there it is. There's your ranking for it. So I kind of made them differently here. So according to the plurality vote, D1 right away. According to a ranking system, it would have been D, A, B, C. So now again, ooh, almost like makes me want to ask here, is D not popular? D is not popular here. How about A? Notice A is popular here. Here, pretty popular. Gets 10 here, right? And gets 29. So on each time, A actually outranks D every single time, except for right here. That one and that one. So in this middle section, A actually outranks D in these candidates. So is A going to be on Condorcet candidate for us? Could be. But in 1.2, we're not talking about that yet. So that's not what we need to do yet. Okay, so that is 1.2. 1.2 is just using the plurality vote, get the answer, get the player, but just kind of thinking back in your head, like, maybe that's not the fairest thing out there. Okay, and the last one, here it is, 1.3. It's called the Borda count method. And so this one, like a different method of counting. Is it more fair than the other one? I'm not sure, just the rules are made up, right? So let's see what the rules are. It is first the second most commonly used method for determining winners of election. So 1 point is assigned to last place. 2 points is assigned to the second to last place, and so on, all the way until you get to the first place winners. So each first place vote is worth n points, and then you count. So the number tallied scores is the way it's earned. So last place gets 1 point, second to last place 2, up until the highest points totaled. Okay, so let's try one. Let's look at one. So now we get into a little bit of math here. So, and we're going to reuse our elections here just so we don't have to look at new numbers here. So remember the math club. So we had that, and the math club tallies were 14 gave it to Alicia, 10 gave it to Carmen, 8 gave it to Dave, 4 gave it to Boris, and another one gave it to Carmen. So let's go with it here. So looks like, so since we only have 4 people here, 4 people present, fourth place is going to be the last place. So we're going to build this little point system in here. Fourth place is last place. That gets only 1 point. Third is going to get 2 points each. Second is going to give us 3 points each. And first is going to give us the whole 4 points because there's 4 people here. So down here, since there's 14 people that have voted for D as last choice, D gets 14 points. Because there's 10 people that voted A as the last choice, A gets 10 points here. And then so on and so forth. So yes, you're going to have to build this out in the homework assignment in order to do this here. So 8 points for A here, and then so on. So now we go on to the second system. So this one is worth 2 points apiece. C gets third place in this ballot. So 2 times 14 gets 28 points. So a little bit of math here. You may want to use a calculator to calculate this here. This will help. So second place winners 2, but second place for D gets 20, and so on and so forth. You kind of keep on climbing. Then this one, everybody gets multiplied by 3, everybody gets multiplied by 4, and now the question is who won? Let's tally all these points up. Let's see what happens. And if you want to try this, just to feel it out, go for it here. So I'm going to give the answers here real quick here. So there it is. So we tallied all the points for A. So for Alicia, all the points for Alicia totals 79. Whoa, hold on, this is crazy. B, Boris, if you tally all the points for Boris, he actually gets 106. He becomes the president. Carmen comes in and she is 104. Actually, Boris beats Carmen. Whoa, okay. So D, Dave still gets the second to last place now. So it gets 81. So no, let's go back to our little pieces here. Did we even think about B being on the higher totem pole here? Yeah, look at that. B was second choice here. B was second choice here, third choice, and then he won over here. That's first, and then it was B. So grand total, he got the majority. He should be president. No, A should be president. No, B should be president. I'm not sure, but depends on the voting system. Notice A, Alicia, she's actually in third place now, right? 106, 104 now. No, actually, she's in last place, 106, 104, 81, and 79. So fair or not fair? Your choice, right? Because it's all about how the voting system is made, how the rules are made, and how the counting is going to take place. That's what you're looking at. All right, so according to the Bordeaux counting method, Boris wins the election. He is the president. According to the plurality method, Alicia was president, but now she comes in last place. And a complete ranking is Boris first, Carmen second, Davis third, and Alicia last. All right, so one little thing is there are a lot of places that use the Bordeaux counting method, especially when people are not sitting in the same room, especially when the things have to be handed out to, let's say it's an email system, or people are being ranked. A good one would be the Heisman Trophy. That would be a good one to do. It's a truncated ballot system, just like this here. You choose first, second, and third place, and from a large list of candidates, and then from there, then the points totals are given. So 3, 2, 1. So the Heisman Trophy is made by the Bordeaux counting method rules. The Cy Young Award, again, same thing. It's a truncated system of modified Bordeaux method here. All right, and I put this on there. That was kind of cool here. Just some information about the Heisman Trophy winner. Did you guys know? Originally only players east of the Mississippi were eligible. Since 1936, all football players in all divisions. So the West Coast was not included in the counting of it. So there are 3 categories of eligible voters. This is how it's done here. So you got sports journalists. They can give their vote. Previous Heisman winners, they give their vote. And then there's fans that are selected, and they actually give their votes too. And so it's, could you imagine, it's a fan-based system. They're collected through ESPN, and then after that, they're given 1 vote as players. And so this one, so 145 voters from each of the 6 regions. So that's not cool. There's only 1 fan vote, and there's 871 media votes. And so then there's 57 prior eligibility. So it's really sports journalist heavy, really, on this position. Okay, so let me do this here. Let me go to here. Let's see, how do I want to do this here? We got just a few more. I think we have some homework questions to do. But let me jump to this. I did have a video here. Let's see what this is. Oh, yeah. So in the last Heisman Trophy. So I went and I just looked at the last Heisman Trophy winner here. This guy's great. There's the fan base here. This guy stood up. And so I thought it was kind of cool. Well, the person, I forgot his name. Can't remember his name now. The person I won it last time here came from a impoverished neighborhood. Was I want to say he was homeless for a while, and lo and behold, he wins the Heisman Trophy winner right here. So here's a video clip of it.
It's my pleasure to announce the 2019 winner and 85th recipient of the Heisman Memorial Trophy is Joe Burrow, Louisiana State University. Congratulations, LSU.
Yeah, there's a whole speech that he gives, but it's the fact he just comes from such a poor family background, and he comes up and wins. That's kind of cool. All right, we'll stop there. Stop there.
It is my pleasure.
So let's go with it here. Exercise on homework. Here it is. So showing the preference schedule for an election of 4 candidates. Here it is. A, B, C, D. We'll call them Alicia, Boris, Carmen, and David. Dave, can you use the border counting method, not the plurality method? Use the border counting method in order to find the winner. Then after that, give me the complete rankings. And so we'll go with it here to see what happens. So I'll do the work here for you because I think you'll have enough homework to do. With that said, but let's jam with it here. Let's do this one. So first place will get 4 points, then we go 3 points, then we get 2 points, and then we get 1 point. So there's a little bit of tedious mathematics here to go through. So probably the easiest way to do it is you just kind of just say A, B, C, D, and then you just start counting for that specific person here. So I'm thinking, okay, let's see, 4 points. Let's see all the four pointers. 4 times 21. That's this one right here. Then you go down to the second level, it's going to be 3 times 18. We go down, 2 points. He came in third place twice here. So 2 times 29. And then also 2 times 10. So you can either multiply 2 times 29, 2 times 10, whatever, to get it done. And then last place, one time you ranked last place, which is right down here. So it'd be 1 times 1. All right, counting that up should give you 21, but just kidding, 217. All right, counting for B, let's go back to the point system again here. So B times 18, which is right here. This is you got fourth place with 18 votes. I'm sorry, first place with 18 votes. 3 times 10 plus 1. It's these two right here that we got. All right, and then he gets third place over here at 21, so it's 2 times 21. And then did he ever get last place? Yes, he got last place here. So it'll be 1 times 29, 29 times he got last place. Add it all up if you need to. And we should get 176. All right, C. Okay, and then kind of just follow along with me. You don't need to do the math here, but follow along, see if my math is correct over here. Just want to make sure. Okay, you look, and I'm going to put in some points, and you tell me if I'm correct here. Or tell me if I'm incorrect here. Plus, we're looking at C again, right? C came in third once with 18 points. And then notice that C is never in last place. There's never a 1 pointer for C. So if you add those up, gets you 230. Oh, looks like C may be our candidate right here. Let's see, let's look for D. D came in on the 29 number ballot as first place. Then came in dead last. Second to last on that one ballot. And then came in dead last for 3 of those ballots. Ooh, that's not going to get a lot of points there. So grand total is 167 are. Wow, look at this again. So on the plurality system, if you guys remember this one, right? D1, Dave won. On the board accounting method, totally different. C is the winner here. In fact, if you want to do a ranking, no, the ranking is going to be very different from the one that we did in 1.2. So C is our winner. The ranking system is C. Then we got A, then we have B, and then D. So Dave comes in last, where he was actually president the previous time. So hopefully you just kind of seen this here. Seen this is that rules change so much. How it's made to count changes so much of who the winner is. All right, so with that, I'll stop the lecture here. So we just discussed 1-1, 1-2, 1-3. On the next office hours on Thursday, we'll go with 1-4, 1-5, 1-6 to finish off the chapter.